Hi, this is Mike Hendrickson from Strata Data in San Jose. I'm here with Dinesh from IBM. Dinesh, how you doing?
I'm doing great.
So you get a great talk this morning, and you talked about enterprise ML. Can you unpack why that's different than just ML?
Right. So if I have to look at pure vanilla ML or an ML that you do for a competition, it's completely different than an enterprise ML for a few reasons. There are no cleansed data set that nobody's going to give you. The data is sitting in silos. If you take a bank, for example, your personal data is sitting in one data warehouse or system, right? And then your credit score is coming from a completely different system. So you have to bring all the data together, clean the data, prep the data, build the model, test and tune the model, deploy the model, monitor the model, and that's a cycle. That's an iterative cycle that could take a long time for you to build the model. Competition is different, right? Because you get the cleansed data, you have a clearly defined use case, a problem to solve. None of those things exist in enterprise. So the enterprise ML, I think, is completely different than what you do on a Kaggle competition.
And so this enterprise ML, as you said, it's a cycle. Right. And that's a continuous or fluid cycle. It's not going to stop because you're always going to have to keep it on and learning.
Right.
Is that?
Right. So that's where, at my talk, I talked about the fluid ML. Fluid ML is basically an enterprise machine learning model that's always on, always learning, because it can never stop. I mean, fraud doesn't stop at any second of the day. I mean, every time they are figuring out how to do fraud in a different way. So you got to have it always on and always learning. That's where we came up with the term fluid ML. And there's 5 pillars to the fluid ML. And if you can get all those 5 pillars right, then I think you have a really well thought out enterprise machine learning model ready to deploy.
And what are those 5 pillars?
So you're testing my memory, but it should be able to be measurable, meaning how do you monitor the model? It should be able to continuously learn, meaning how do you make sure that you add a feedback loop to it to retrain it using real-time data. It has to be performant, meaning most enterprises want the model scoring done in less than milliseconds. How do you make sure a real-time model can score in milliseconds? It has to be resilient, meaning if a data comes in null, are you ready to treat that error condition? So if you can bring all those pillars together, if you have done all those pillars, I think you're in a really good condition.
Does scalability fit in resilience, or does
yeah.
it? Yeah, okay.
It has to be scale. I mean, because if you are putting a model real time, then obviously you need to be able to deal with thousands of transactions coming in, or even hundreds of thousands of transactions. So scalability is huge. So all those testing, resilient meaning it should be able to treat the error condition. It should be elastic. It should be able to scale. So all those parameters come under that particular umbrella.
The folks at IBM, including yourself, you guys work with a lot of large enterprise companies. And do you see that any of them really have a good handle on building models for ML, or is that a struggle? Is that a ongoing, it's not easy to do?
Right. So I think everybody is in agreement that they need to infuse machine learning into their enterprise. I don't think there's not a single enterprise that I've met who doesn't agree with that. But the challenge is that how do you now bring that machine learning into your 40, 50, 100-year-old infrastructure that exists today, right? I mean, you have third-party application that you cannot touch. You have legacy software that you don't want to touch because if something breaks, your enterprise comes down.
Potential silos around the company.
Yeah, I mean, and every division has their own set of data. They keep all those. So that's the challenge that enterprises face. Not the fact that they all agree that machine learning need to be an integral part of their future, but how do they infuse the machine learning? I think when I look at machine learning, I call it the 3Ds, and I got a lot of Twitter on what are the 3Ds. It's the data, the development of models, and the deployment of models. I would say enterprises probably spend 80% of their time on the cleansing of the data and the deployment of the model. The development of the model is getting more and more automated. I mean, at IBM we have auto modeling, for example, and a lot of vendors do that. So that piece is getting more and more easier, but the deployment of the model is where you need the experience, you need the skills, and you need a lot of help. The data cleansing is another piece you also definitely need a lot.
Would you recommend building up and on top of these old large legacy systems, or would you spin off a new cluster and a new maybe division or part and do it from the ground up? I mean, which is the better, build on or build out?
Right. So if you are building new applications, definitely that second piece makes more sense. But if you are a large bank that existed for 50, 60 years, you have existing infrastructure where your transactions are running seamlessly. How do you make sure now instead of rules, how do you put machine learning to detect fraud? There's no way around it. You have to build machine learning or learning into the existing infrastructure.
On top of the infrastructure they have.
Yeah. There's no way around it. We have seen it over and over again. I'll give you an example. So we worked with a major credit union in the United States about loan approvals and how do you have the model do the loan approval instead of the underwriter. There is also, what we learned is very interesting, is that the model itself was not approving some loans that's coming from a particular zip code. And all of a sudden, that's where I talked about resilient to make sure that how do you test the error-prone situations. And it turns out one underwriter wasn't giving loans to that particular zip code. So, not only it will expose a lot of things for us, but it will also help the enterprise from 3.5 hours to approve an auto loan. They went to minutes using the machine learning model. So there's benefits, but it also exposes a lot of the quirks that comes with, the previous way of doing loan approvals and other things.
So you've worked with a lot of companies around the world. Can you identify maybe 2 or 3 things that are the biggest challenges for large companies to get started with machine learning? And then also, could you also identify what are going to be the biggest 3 benefits?
Right.
2 or 3 benefits?
Right. I would say if I have to summarize it, the biggest challenges are, 1, identifying a problem. Not every problem needs machine learning. But now there is this craze going on that, we need to have machine learning.
Because everyone's doing it.
Right. And some people are even saying deep learning. And my take is that I would say 85% of enterprises' challenges could be, dealt with vanilla machine learning. But people are going to the other extreme saying that, well, no, I need deep learning. And deep learning also has its benefits, but it also has its challenges. You need tremendous amount of resources to do the training. Once you train, what do you do with those resources, right? So that's 1, identifying a problem where you really think machine learning needs to be in place. That's the 1. 2, the data, because garbage in, garbage out. If you cannot get clean data, that becomes a huge challenge. And data today exists in silos in many enterprises, if not all. So how do you bring all the data cleansed to do that? The last but not least, I would say, is the challenge that enterprises, once you build the model, how do you deploy that model? How do you bring that into your existing infrastructure? Those are the 3 challenges that we see over and over again is, and then dispersion of skills, all those things are there. But if I have to summarize it as the core 3 challenges, those are the 3. Now, when we talk about benefits, it's huge. 1, you have the benefit of now a machine that is available 24/7. It's constantly learning. So I'll give you an example. Let's say you're an airline. You as an individual, the airline has all the data, but now the machine is learning that you like to go to a bar if you miss the plane, or you like to go home as soon as possible, or you like to get a massage or whatever. So based on your likes and dislikes, the machine has learned to make a prediction to send you to the right agent, right place, whatever else you need, right? So I think the benefit is that we as consumers will definitely benefit huge from a serviceability perspective.
So the corporations will benefit by being closer to their customers.
Exactly.
Right.
That's 1. Cost is another one, right? Now all of a sudden you have a machine doing everything to a large extent. So that's another benefit. And the third, but not least, is it gets them into a next level of the playing field, because now you are not just making decisions based on the past, but you're making decisions on real time based on the real time data coming in. So before, analytics was to be, okay, you take the data, put it into a data warehouse, you run reports on it, or you do analytics on it. But now it has become, there is no more analytics on data that's a day old or an hour old. Now it's data analytics or machine learning or predictability on data that's seconds old. So that's a huge benefit. So I would say those are some of the benefits that, as an enterprise, that you get immediately.
Excellent. Well, Dinesh, we look forward to seeing you and your colleagues help this unfold in enterprises.
Well,
thank you.
Thank you so much. Appreciate the time.